Hello students, welcome back to RD Chemistry. In this video, I'll explain the concept of osmotic pressure and we'll solve some problems. So let us start now. Here I'm going to discuss osmotic pressure for non-electrolytic solutions. Means solute particles are non-electrolyte. They do not undergo association or dissociation. Therefore, we are not going to include the Van 't Hoff factor. We have the formula osmotic pressure pi is equal to CRT, right? Where pi stands for osmotic pressure, C is the concentration in terms of molarity. And we know that molarity M is equal to the formula number of moles of the solute divided by volume in terms of liters. R is the ideal gas constant. So depends on the pi value, whether it is the atmosphere or pascals. T is the temperature in terms of Kelvin scale. So I can write pi is equal to number of moles divided by volume in terms of liters into R into T, or which is equal to pi V is equal to nRT, right? Now I can also write pi V into number of moles can be calculated as given mass of the solute divided by molar mass of the solute into RT, right? Therefore, finally we can write, if I want to find out the molar mass of the unknown solute is equal to WRT divided by pi V. Okay, right? Now see this concept. If V1 ml of C1 solution, C1 is the concentration for solution, with the V2 ml of the C2 solution mixed together, then calculate final concentration of the solution and final osmotic pressure if initial osmotic pressures of two solutions are pi 1 and pi 2 respectively. Now I want to calculate osmotic pressure of the final solution. Should be equal to C into R into T. R is a constant, temperature, given temperature is also constant. C is the concentration of the final solution. When I say final solution, is a mixture. Okay, mixture. Okay, so concentration of the mixture that is produced. But how will I calculate the concentration? Remember students, suppose I want to find out the molarity of the mixture final solution after mixing two solutions. We have the formula M1 V1 plus M2 V2 divided by V1 plus V2, right? Now here the concentration term M1 is nothing but C1, M2 is the C2 and corresponding volumes. So how to calculate concentration the final, which is equal to, it is a C1 V1 plus C2 V2 divided by V1 plus V2, right? Clear? Therefore, now let me substitute. The osmotic pressure of the final solution is equal to C1 V1 plus C2 V2 divided by V1 plus V2 into RT. Correct? Now this is in terms of concentration and volume. Can I write in terms of osmotic pressures? I can write up osmotic pressures. For the first solution, we have got C1 is equal to pi 1 is equal to C1 RT. First solution, individual solution. For the second one, pi 2 is equal to C2 into RT, correct? Therefore, concentration C1 is equal to pi 1 divided by RT. Similarly, concentration C2 is also equal to pi 2 divided by RT, correct? Now, instead of writing C1, C2, I can write in terms of pi 1 and pi 2. So therefore, the osmotic pressure of the final solution is equal to C1 pi 1 divided by RT into V1 plus C2 is equal to pi 2 divided by RT into V2 whole divided by V1 plus V2 into RT, right, into RT. So we'll simplify this one. The common term is RT, so 1 by RT into, it is the pi 1 V1 plus pi 2 V2 into RT divided by V1 plus V2. So this is equal to RT get cancelled. Finally, the osmotic pressure, the final solution can also be equal to, in terms of pi 1 V1 plus pi 2 V2 divided by V1 plus V2. See this formula. This is in terms of pi and V. RT is not there. And see here, this one. This is in terms of C1, V1, C2, V2, where RT is included. Okay, right? Yeah, read this question. Osmotic pressure of 30% solution of glucose is 1.2 atmosphere. That of 3.42 percentage of cane sugar is 2.5 atmosphere. Osmotic pressure of the mixture to calculate containing equal volumes of the solution. There are two solutions. This is the pi 1 and this is the pi 2. Two osmotic pressures are given, but we'll have to calculate osmotic pressure, the final solution or the mixture. Just now we have seen one formula, which is that pi 1 V1 plus pi 2 V2 divided by V1 plus V2. Volumes are not mentioned, they are saying equal volume. When I say equal volume, let it be V in both the cases. So I'll be writing pi of the final is equal to pi 1 V plus pi 2 V, just simply V, divided by V plus V, correct? Therefore, pi F is equal to pi 1 plus pi 2 with a common term there. Then here it is a doubling the volume, equal volume, doubling the volume, 2V. So V and V get cancelled. So finally I can write the osmotic pressure final solution is equal to pi 1 plus pi 2 divided by 2. If there is the equal volume, add the 2 osmotic pressure divided by 2. Therefore, in this case, it is 1.2 plus 2.5 divided by 2, which is equal to 3.7 divided by 2 is equal to 1.85 atmosphere. Hope this is clear to you, right? Read the second question. A substance containing 1.05 gram per 100 ml was found to be isotonic with 3% weight by volume of glucose solution, and this is the unknown solution. First one, molar mass of the solute in the unknown solution, and find out. First of all, what do you mean by isotonic solution? Isotonic solution means two solutions have got same osmotic pressure. That means osmotic pressure of the first solution is equal to osmotic pressure of the second solution. And we know that pi is equal to CRT. C is the R and T are the constant. The pi is directly proportional to concentration. Therefore, concentration of first solution should be equal to concentration of the second solution. How do you calculate concentration? Concentration is equal to number of moles of the first one, solute of first one, divided by the volume is equal to N2 divided by V, volume in terms of liter. Now here, so this is a 1.0, here, this is a 1.05 gram per 100 ml, right? Correct? 100 ml. 100 ml means 0.1 liter. Now what is the meaning of 3% weight by volume, which means it is a 3 grams in 100 ml. Percent is always out of 100. Weight by volume means this is a weight in 100 ml, percentage wise. So both are out of 100 ml. So volumes are same, right? How do you calculate number of moles? Number of moles are equal to given mass W1 divided by molar mass is equal to given mass divided by molar mass, right? So first one for the unknown substance and second for the glucose solution. So therefore, first one 1.05 grams divided by molar mass you have to calculate is equal to 3 for glucose 3 grams divided by molar mass of glucose you have to remember how to calculate. Okay, so it is 180. Therefore, M1 is equal to comes to be 63. What is the unit of molar mass? Gram per mole. So the answer is 63 grams per mole, right? Yeah, read the third question. A solution containing 4 gram of polyvinyl chloride polymer in 1 liter dioxane found to have osmotic pressure 6 in 10 power minus 4 atmosphere 300 Kelvin. Molar mass of the polymer is. Weight is given is equal to 4 grams. Volume is given in terms of liters. And osmotic pressure in terms of 6 into 10 power minus 4 atmosphere. Temperature T is given 300 Kelvin. Molar mass you have to calculate. We have the formula, right? What is the formula? Molar mass is equal to WRT divided by pi into V. So W is equal to 4 grams into R. The value of R depends on, see here given atmosphere and given here liters. In that case, R would be equal to 0.0821 in terms of atmosphere, liter per mole and per Kelvin. So I'll be substituting 0.0821 and temperature is given 300 Kelvin divided by pi value 6 into 10 power minus 4 into volume is equal to 1 liter. This is equal to 16.1 into 10 power plus 4 comes, which can also be written as 1.6 into 10 power 5. And what is the unit of molar mass in terms of gram per mole? The large number because this is a polymer. Clear? Hope this is clear to you. Keep on supporting RD Chemistry. Please do like, share and subscribe. Thank you for watching.